All right, on the agenda today is section 1.4. We're going to be taking a look at trigonometric functions on the unit circle. And the unit circle is going to be our starting point to talk about, and then we'll expand to what it looks like to do trig on the unit circle. So our leading idea is, at first, sine, cosine, and tangent made sense with right triangles, clear sides, and angles we could see. But the unit circle asks us to think differently. It might not feel obvious at first. And that's where faith comes in. Not blind belief, but trusting that the patterns that we already know, Just like the unit circle expands our understanding without replacing what we've learned, God's plan expands beyond what we can see or understand, but his truth remains consistent. As we explore angles, let's hold on to that same trust, believing that just as math's rules are steady, even when the view changes, God's faithfulness never wavers, even when life looks different. Let's pray. Dear Heavenly Father, I thank you for an opportunity to be here. I thank you for the long weekend that you gave us, and I thank you for a chance to look at new material and look at it in a different way. I pray that as we move forward with the unit circle, that the details and the patterns would be clear and would bring more understanding to what we've already been established and learning. We pray in Jesus' name. Amen. Okay, so we've taken a look at these 6 trig functions 2 ways so far. The first way we looked at them was with triangles, which had opposites, hypotenuses, and adjacents. So shake your head if that sounds familiar. Okay, that's the one that feels the most comfortable, like that we talked about in the leading idea, right? We saw a triangle, okay? The second, the way we looked at them was we looked at them in regard to being on a circle, and we looked at them having X's and Y's and R's. So there was like a point in space. We drew the radius back to the center of the circle. There was an arc that was created. Radius R was found by the Pythagorean theorem. Does everybody remember what we're talking about that way? Okay, good deal. All right, so what we're going to do in this unit is that we're going to do the same thing with that point, except that the R value is always 1 because we're on a unit circle. Unit means it has radius 1. Okay, that's the difference, is that the R is going to become 1. Now, when we take a look at doing this, what happens is that all of our ratios, well, not all of them, but 4 of them anyway, they change and they simplify slightly. So our sine value, if you remember, was y over r. Okay, remember sine goes with y, cosine goes with x. So the sine value was y over r, but if r is equal to 1, that means that the sine value is simply y. So this one's y. The cosine value is x over r, but if r is equal to 1, that would be x over 1, so I'd simply have x. The tangent value was y over x. That doesn't change because there's no r involved. So his definition remains the same. And then, as we've seen in all the other cases, cosecant, secant, and cotangent are reciprocals. So we're just going to flip all of them. So y is becoming 1 over y, x is becoming 1 over x, and cotangent is becoming, I meant to say secant. Secant is becoming 1 over x, and tangent is becoming x over y. So we get the reciprocal of all 3 of those.
So no matter what, R is 1.
R is 1, exactly. So when we're dealing with a unit circle means it has radius equal to 1. Yes. Okay, so it's the ordered pair notations that we were dealing with last time, but the specific case where R is equal to 1. So the first thing you see is that you've got, if you've printed these out, you've got a little tiny picture and you've got a big giant space of emptiness on the page, right? You need that big giant space of emptiness, but we'll start by taking a look at the little piece at the top. So this is an example where the radius is equal to 1, okay? This is R equal to 1, and this is an ordered pair on that unit circle. Negative 5 over 13 and negative 12 over 13. And if we put it into the Pythagorean theorem, x squared plus y squared, it would equal 1 squared or 1. Okay, it would work. But they're giving this to you. This is a point on the unit circle, corresponds to the real number t. We're going to find the values of the trigonometric functions. Okay, there's 6 of them. Write small because you need lots of the space at the bottom for the next piece we're going to do. It's going to be much more space intensive, okay? So we're going to talk about sine first. Oh, and it's t, so I'm going to do sine of t. It's telling you that the angle is t on this one, so we'll do sine of t. If that really bothers you, change all the t's to thetas and call it sine of theta. It doesn't really matter. All right, so taking a look at this, the sine value is supposed to be what? Over here, what did it say? Y, right? The sine value is y. So what is the y value of this ordered pair? Negative 12 over 13. You got it right there, yeah? All right, I'm going to put my cosine underneath it because my space works out better that way to do it, and I'll put the reciprocals next to them in a minute. So like I'm going to put cosecant over here so that they are going together side by side, but instead of going left to right, they're going to go top and bottom, or instead of going top to bottom, they're going to go left and right. Cosine. Cosine is supposed to be what? X. What is the x value? Negative 5 over 13. And if we have those, right, then the cosecant and the secant are, we almost get them for free. I don't want to say they're easy, but we do. We almost get them for free. Because all I have to do is to take the value that I've got, and I've got to flip it. Right? Like, I don't really need to do 1 divided by negative 12 over 13. I just need to flip it upside down, and that will give me the same value simplified already. So this is negative 13 over 12 and negative 13 over 5. Does that make sense so far? Okay, so everything we've talked about with sines, we're not changing any of it. We're just changing how we're looking at it in a specific location in space, the radius equal to 1. All right, the other 2 we need are the tangent and the cotangent, right? Now, this one's the one that looks funny because cotangent has the t at the end, and now I've got the angle t. It's not my favorite, but they do use t sometimes for angles, even if it's not quite as common. Now, tangent is supposed to be y over x. And that's a little bit messier here, so I'm going to do a little bit of work down here. If I do my y value, it's negative 12 over 13. Over my x value, it's negative 5 over 13. Right? Fractions over fractions, not particularly pretty looking. But we've talked before that all that means that we are going to do is we're going to flip the denominator upside down. So it's now 13 over 5. The negatives are both there as well. As we take a look at simplifying this, okay, so the negatives are going to cancel to positives. And notice the 13s also cancel, okay? And this is pretty common when we work with tangents, is that we see some diagonal just flat out canceling out. And if not canceling out completely, at least reducing, okay? So as we take a look at this then, what do we end up with? Close. Positive 12 over 5. Yeah, both of them are negative, so the negatives divide out to be positive. So we have 12 over 5. Now, don't go doing more work than you have to. I don't need to go through this whole process again for cotangent, right? If I already know tangent, what do I do to find cotangent? I flip it. So it'd be 5 over 12, right? That's not a very good 5. Let's try that again. That's better, 5 over 12. Okay, so just a real quick check step as we reminded ourselves from last time. We talked about a smart trig class. Nod your head if that sounds familiar, right? It told us what kinds of values in terms of positives or negatives we get in which quadrants. So in quadrant 3, down here where we are, we should be getting sines and cosines that are negative. And you see that, right? Along with the reciprocals. And we should be getting tangent, and its reciprocal to be positive. So checking to make sure that we see that at the end also can help us from making a mistake on a sign error that we just lost a negative on or something like that along the way. Okay, does that make sense how we interpret this diagram? Okay, so the next thing I'm going to do is I'm going to actually draw a unit circle. Okay, so if you want to draw this with me, great. That's what I'm talking about needing on your extra space in the bottom here. If you don't want to draw this and you want to like later on print one off from online, just Google unit circle. They're out there. There's plenty of options and you can do it from there too. But let me talk with you about how this takes its form. It feels like it's overwhelming. It feels really big. But there's actually really only 2 things you have to remember. Okay? The 2 things that you have to remember, well, 2 points on the sides that you have to remember is what I meant to say, are this one and this one. Okay? So let me actually establish the quadrantal angles first because those are the easiest ones. This point over here, since it's a radius 1, is the point 1, 0, right? I'm 1 away from the units or from the center. That's an x value here. The one at the top is 0, 1. Again, I'm 1 away from the center. That's the y value. What would the one over here on the left be? Yep, it's negative 1, 0. Somebody else tell me what you think the one on the bottom is.
0, -1.
Yep, 0, -1. Okay, so there's really not a matter of like you need to remember these. They're pretty straightforward. So the 2 points that I marked as being ones that we want to remember, okay, we're going to look at those first. This particular point right here is square root 3 over 2, 1/2. And the one after it is square root 2 over 2, square root 2 over 2. I want to write the whole unit circle in, and then I'm going to talk about where these values come from, okay? They're not really like, they're not coming out of nowhere, promise, okay? And we've actually seen them before as well. But let's actually just look at the patterns within the unit circle in terms of how do I remember this thing first? Here's the cool thing. Every ordered pair on the entire circle is one of these two, or almost. So we're just going to go around the unit circle, you know, counterclockwise like we would if we were going on our angle measures, okay? The next one that's up here in the top right-hand corner, top right-hand corner, is going to be the same thing we have at the beginning, that square root 3 over 2, 1/2, but flipped, x and y switches. Okay, so this is 1/2 and then square root 3 over 2. So if I remember the first two, I just know the third one switches the first one, flips them around. Everything over in quadrant 2 is going to be the same things, right? Like mirror image from the left to the right, except there's going to be some negatives involved. What's going to be negative? X or Y? X. Okay, so it's the same values, mirror image, with X is negative. So this first one is negative 1/2, and then square root 3 over 2. The second one is negative square root of 2 over 2, square root 2 over 2. And the last one is negative square root 3 over 2 and 1/2. I don't have to remember them. It's a pattern. If I have the first quadrant, I get the second quadrant, again, pretty much for free because of prior knowledge we've worked on. The same thing happens when I take quadrant 3 and I reflect it down into quadrant 2 and reflect it down into quadrant 3. All the same values persist except what's negative? X and Y. I've got negatives on both of them now. So the first one, ordered pair, if I flip it down, I'm flipping down the square root 3 over 2 down here. So it's the flipped, whichever one's closest to the x-axis is still close to the x-axis. Whatever's closest to the y is still close to y. So this one down here is now negative square root 3 over 2 and negative 1/2. And then the next one is negative square root 2 over 2, negative square root 2 over 2. And then the last one is negative 1/2 and negative square root 3 over 2. One more quadrant to fill in. So you can either think of taking quadrant 3 and flipping it to the right, or you can think of taking quadrant 1 and flipping it down. Doesn't matter. I'm going to keep going around the unit circle sort of in order. But what's going to be negative in quadrant 4? Y. So x is now positive, y is now negative. The first one in order right here would be negative square root 3 over 2. I didn't say that right. Positive square root 3 over 2. My apologies. And then negative 1/2. That's the one we want. So just the y is negative. The next one is square root 2 over 2 and negative square root 2 over 2. And then our last one is, oh man, I did it backwards, didn't I? Okay, that's what happens. Erase. My apologies. That's the one I want. I flipped these around. Let's move them back. I was looking at the wrong piece. I need 1/2, and I need negative square root 3 over 2. I should have reflected this one down here if you want to think of it that way, or this one over here, and I didn't do either. I flipped the wrong one. Okay, get my back. And then I have square root 3 over 2 and negative 1/2. Okay, do I have them all in there now, right? As I was doing all my patterns. Okay, so this is the pattern of the ordered pairs. So when you get to this quiz that we're going to do on Friday with the unit circle, right? The quiz is not to create this circle. I'm not quite done finishing the circle, but you do have a space on there that if you want, you can fill them all in on the circle to start with so that you can reference it as you're answering the questions, okay? I'd encourage you to do that. I think it makes it a lot easier than trying to remember all the pieces at the same time, okay? So what else we need to do is we need to put in the angle measures. We need to do the angle measures in terms of radians and degrees, okay? So I'm going to do degrees first. That's the one you're probably most comfortable with. So the first angle measure is this one right here at the middle is going to be 30 degrees, okay? The next angle measure is 45 degrees. And then the third one over here in quadrant 1, trying to get it over there. Yep, somebody said it is 60 degrees. Oh my goodness, and it zoomed in. I didn't mean to zoom in. I'm sorry about that. Okay, 30, 45, 60. Okay? So, how can we remember that? Well, if you take a look, the first one's 30, right? And then I add 15 and I add 15. Or you can say I take the 30 and I double it, okay? And then, of course, all the way to the top, this would be 90 degrees, right? Okay. I'm going to stop drawing these arcs, and I'm just going to write it on the line that extends, like the radius that extends, so I can stop having so much going on in the picture. So if you notice, from 60 to 90, how much did I add to get from 60 to 90? 30. So I'm going to add 30 to get to the next one, too. So if I go from 90 and I add 30 more, what am I at? 120. So this one right here is 120. And then I'm going to add 15 to get to the next one, right? The 3 in the middles are always adding 15s. So if I add 15 to 120, I'm at 135. And if I add 15 again, I'm at 150. And then notice that checks out because I should add 30 to get to the next side, and that's 180, which we already knew, right? If I go all the way over from the left to the right or the right to the left, either way, it's 180 degrees that I've gone, okay? So let's fill in the next one. So this mark right here would be 30 more. So what am I at? 210. And then I need 15 more. Nobody wants to talk. 225. And I'm at 15 more after that. 240. And then 30 more puts me straight down at the bottom, which is what? 270. Okay, keeping going. 30 more after 270 gives me 300. 15 more after that is 315. 15 more after that is 330. And then if I add 30 more, where am I? 360, back to the beginning, and we're good. Okay, everybody good so far? That's your degrees. There's a pattern, right? The patterns are adding 30s and 15s. Or you can actually think of it a different way if you wish. So these ones that are sort of in the middle at these markers that have 5s on the end, they're each of the ones divided by 2, right? It's 90 degrees, and I've halved it, so I'm at 45. Halfway between 90 and 180 is the 135, and so forth all the way around. The other ones add 30. So I've got 30 and 60, and I'm at 90, I'm at 120 and 150 and 180, like they add 30 every time. So whichever of those methods sort of makes sense to you in terms of patterns, that's what's going on. Let's look at the radians now, because the radians are the ones that trip people up a little bit more. I'm going to change colors. Hopefully this one will work okay in terms of it being visible. So my 30 degree, in fact, let me do this because I had changed the way I was doing it to show you better. Let me put those in the way I was doing them before. So this is 30, 45, and 60, right? Here we go. All right, so at the 30 degree mark, that's actually equivalent to pi over 6. I'm not going to belabor the point, but we've seen that measurement show up before. Now, instead of going around, I want to actually show you how I remember the pattern. You guys good with that? Okay. All the angle measures that are close to the x-axis, which in terms of degrees are the 30, the 150, the 210, and the 330. Those 4 of them are all values over 6. So it's pi over 6 on the left. It's 5 pi over 6 on your right. I'm sorry, I'm saying get my lefts and rights backwards. It's 5 pi over 6 in quadrant 2. Let's go with that. Down in quadrant 3, I'm at 7 pi over 6. And over in quadrant 4, I'm at 11 pi over 6. Okay, those are my over 6 values. All of the next ones, so we'll go in order now. So we'll go back to the one that's at the 45 degree. The 45 degree is always going to be values over 4. So we're over 6s. Next, we're going to be over 4s. So this is actually pi over 4. And then the corresponding piece over in quadrant 2, which is the 135 degree angle, is 3 pi over 4. The one down here in quadrant 3 at the 225 is 5 pi over 4. And the one over here in quadrant 4 is 7 pi over 4. Those are really nice. It's just the odd values of pi over 4 of 1, 3, 5, and 7. Okay? Last piece are the ones that are closest to the y-axis, right? They're at the top and they're at the bottom close to the y-axis. These values are going to be over 3. So this one right here is pi over 3. The next one is 2 pi over 3. If you're counting up, 3 pi over 3 would actually be on the x-axis to the left. So that's not my next one. I actually get down to 4 pi over 3 down here. So this one's 4 pi over 3 down here in quadrant 3. And then the next one is 5 pi over 3. And if we get to 6 pi over 3, I'd be back where I started because 6 over 3 is 2. It'd be 2 pi. So my strong recommendation is that you recognize these patterns and remember enough of the pieces to fill the rest of them in. Second option, if you don't like that, is to simply memorize the entire circle. I think that's a lot more work, actually, than to recognize what patterns are going on. But you need to know where these values are and what the corresponding pieces are. So here's the deal. You need to know that if you are at 5 pi over 3, that you're down here and that this is the ordered pair that goes with it. And that's my suggestion for the reason for my suggestion of writing the circle down before you start. Okay? So, what does your actual quiz look like? Your actual quiz actually looks like the next set of questions. Are you ready? They will ask you to find trig values of certain angles. That's what the quiz looks like. I'm going to say, find cosine of 2 pi over 3. Or find tangent of 3 pi over 2. I'll flip back to here in a second. Or, oopsie, they're not there. There it is. Find sine of 5 pi over 4. Or find cotangent of 13 pi over 2. Those are the kinds of things that are going to show up on the quiz. Okay? The circle itself and memorizing the circle is sort of the prerequisite to be able to do the quiz. And there will be a place for you to write that on there, but that's not the graded piece. So let's take a look at how this works. You've got the unit circle written down now, I hope, or at least enough of it that we can make it work. This asks us to find the cosine of 2 pi over 3. Because I don't want to flip back and forth on my screen, I'm going to draw in roughly where we are. At 2 pi over 3, we are right up here. Okay? Everybody good with that? It's the value that's the pi over 3 values are always ones that are closest to the y-axis. So I'm on the y-axis and I'm in quadrant 2. And it wants the cosine value. What is the cosine value in terms of x's and y's and so forth? What did we say at the very beginning? What is cosine? It is x. So what this is asking me for is to remember what that point is, the one that's closest to the y-axis in quadrant 2, and what is its x value. So, taking a look back at your unit circle, what is the x value of that point? Sorry, say it again. There we go. Yeah, sorry. I was not hearing things kind of mumbled. Yeah, it's negative 1/2. Negative 1/2 is the answer to the question. Okay? And if we memorize the unit circle, or enough of it to be able to draw it and then look at it, we should just be able to read it straight off the circle. And that's true for sines and cosines. The reciprocals, it means we flip them, right? So we kind of get to read those up upside down off of the unit circle. Tangents and cotangents do require a little bit more work. So the next one is in fact tangent. So where are we at 3 pi over 2? Where are we? Where's 3 pi over 2? 270 degrees. It's all the way down here, right? That wasn't what I meant to do. Let's try that again. It's all the way down here. Yes? What's the ordered pair down there? 0, -1. And tangent should be the y over x. So -1 over 0. And what is anything divided by 0? Undefined. It's not 0, it's undefined. You can write the whole work out. You can write the word, like the abbreviation UND if you wish. I'm good with that. You can't just write no solution because that has more than one context or value in different contexts. So I do want it to say undefined in some fashion, okay? So this answer that I'm looking for, if this showed up on your quiz, is undefined. How about sine of 5 pi over 4, okay? So these couple are a little different because I don't have, actually, I'm sorry, it's the next one. This one still is on my unit circle, 5 pi over 4 is. Where is 5 pi over 4? What quadrant am I in? Quadrant 3, and it's the halfway mark, right? It's this one down here. So in terms of my image, I'm right over here. What is the ordered pair at that point? You bet. Negative square root 2 over 2, negative square root 2 over 2. And sine values are which values? Y. So what is the y value at this point? Negative square root 2 over 2. There's no work to show. I'm showing work because I want to make sure that you're all seeing it like with me since I'm not flipping back and forth between screens. But there's no work that has to be shown for this. You have to remember what goes with sine, which is y, and you have to be able to discern where you are in the unit circle. 13 pi over 2, however, is not on my unit circle. Okay? This is where those coterminal angles that we looked at back in section 1 come in. I need to figure out where I am if I'm at 13 pi over 2. So I'm going to have to do a little bit of work on the front end of this one to figure that out. I need to subtract off, because this is too big, 2 pi until I'm at a value that is between 0 and 2 pi. So if I subtract off 2 pi, that's the same thing, just as a reminder, because I've got the unit or the common denominators of subtracting off 4 pi over 2. So if I subtract off 4 pi over 2, what am I at? 9 pi over 2. That's still too big. So I need to do a 9 pi over 2 and subtract off 4 pi over 2. That's 5 pi over 2. That is still too big. So we'll do it one more time. 5 pi over 2 and subtract off 4 pi over 2. And where are we? Pi over 2. Okay, so again, do you have to show all of that? No, but you're not going to have your calculator to subtract it for you. Okay, because there's no calculators on gateways. So this is pi over 2. So where are we in space if we're at pi over 2? We're at 90 degrees, exactly. So we're up here at the top. And what's the ordered pair up here? 0 and 1. Is everybody good with that? Awesome. Cotangent. Well, cotangent is x over y. So what's the x value here? 0. And the y value? 1. This is not undefined. Okay, 0 in the denominator is undefined. But if you take 0 and you divide it by anything else, what is 0 divided by anything else? 0. That is 0. Okay, people flip those in their mind sometimes, so keep that in mind. 0 over 1 would be 0. Okay, the last thing in this section is even and odd trig functions. Cosine and secant are even. We're just going to write these down, and then I'm going to talk to you about what they mean. And even trig functions mean that when you take a negative angle, it's the same as taking the positive angle. So the cosine of negative 50 is the same thing as the cosine of 50. Okay? So the negative inside with the angle does not affect the secant or the cosine value. Okay? The angle inside can be negative or it can be positive and you get the same value. Okay, I'll reference the unit circle to verify that with you in just a second. Sine and its reciprocal, tangent and its reciprocal are not like that. They're odd functions. And when you have an odd function, that negative on the inside does change the value. But it changes it in the same way as if there had been a negative on the sine value itself. So we are not moving the negative from the inside to the outside, but it kind of looks like it. Again, I'm going to show you from the unit circle why that happens, but these are the four that this happens for. So I have sine of negative t is negative sine t, cosine of negative t is negative cosecant. Cosecant of negative t is negative cosecant of t. Tangent of t is negative t is negative tangent of t. I need to slow down talking. Cotangent of negative t is negative cotangent of t. Okay, so I'm going to flip back to my unit circle to show you why it's happening. You ready? Okay. All right. If we have cosine and secant, so I'm going to use cosine. Naturally, whatever cosine does, cosecant does. Everybody's nodding their head going, yep, they go together, right? Okay, so I'm going to verify it for cosine, and we get the cosecant, or get the secant for free. Cosine value, if I am at positive pi over 4, I'm up here. And my cosine value is square root 2 over 2 because it's x, correct? If I were at negative pi over 4, I'd be down here. And my cosine value is also square root 2 over 2. And this is happening because on the right-hand side, the x values are all positive. So when I have a positive or a negative, it flips down, right? The angle measure is going in the opposite direction. I get the same value for cosine because it's relying only upon the value for x. Okay, now watch what happens when I look at secant, I'm sorry, not secant, sine. The sine value is the y value, right? It's this one. And what happens when I reflect down? The sign changes because y values are positive in quadrant 1, negative in quadrant 2. It flips, and I end up with a negative value if I'm looking at sine. The same thing happens for tangent because tangent is a ratio of x's and y's. If the x value is not changing signs, which it doesn't from quadrant 1 to quadrant 4, right? But the y value does because it's positive in quadrant 1 and negative in quadrant 4, right? If those are changing, then the x and the y's, one changes, the other doesn't, means that we're going to end up with having a ratio that changed its sign, okay? Now, I'm not going to ask you to tell me that in the future, but I do want you to know it's just coming from the unit circle. What you need to remember is that cosine is even. The negative inside doesn't matter, and it's reciprocal. And then sine and tangent are odd. So let's take a look back at how this plays out and what it matters for in our problems. So our directions say to use the unit circle to find the value of the trig function, and then to use even odd properties to find the other one. Okay, so you notice this is the same question. One says cosine pi over 2, the other one says it's cosine negative, pi over 3, cosine negative pi over 3. The only difference is the negative, right? Okay, so the first one we're going to use the unit circle for just like we did a minute ago. It's not going to be any different. So in terms of the unit circle, what quadrant am I in if I am at pi over 3? I'm in quadrant 1, and I'm at this one that's way up here at the top, right? Closest to the y-axis, right here. Okay, cosine is which value, x or y? X. What is the x? Well, let's just write it down. What's the ordered pair at pi over 3? Right, 1/2 and square root 3 over 2. And what is the x value there? 1/2. So my cosine of pi over 3 is 1/2. But here's the cool thing. Cosine is an even function. Even functions mean, in essence, that the negative angle is the same as the positive angle. So when I'm looking at cosine of, sorry, that's a typo. When I'm looking at cosine of negative pi over 3, because it's an even function, it's the same thing as cosine of pi over 3. And what was the cosine of pi over 3? 1/2. So the cosine of negative pi over 3 is also 1/2. And this is the work you'd show for that. This is not on the gateway, okay? But this is in the homework. It's in this section of the material for the homework, but the gateway doesn't have negative angles. Okay, does that make sense? So if there's a negative angle inside, you have to decide, does the negative not matter, like on this one, or does it matter, and if it does, it moves to the front? Okay, those are the only two things you have to decide on when there's negative angles. Okay, and that's it for today.